Welcome back. So, in previous lecture, we told that we will come back with some case study on earthquake, and today we are going to talk about the Gorkha earthquake, which occurred in 2015, and subsequently there were like 2 earthquakes which occurred in Nepal. Of course, we are fortunate enough that we did not experience much of damage from these earthquakes, although the magnitude was 7.8 and 7.3. There were 2 consecutive earthquakes. One was in 25th April 2015, which was named as Gorkha earthquake, which is shown here, this one, and then another one was triggered on 12th May, and that was the 2015 7.3, which was towards the eastern side of the Gorkha earthquake. Now there are debates, but that these 2 events may be separate events, but looks like that 2015 12th May event with magnitude 7.3 was a sort of a triggered event as resulted by the 7.8 magnitude Gorkha earthquake. Now, if you look at the Himalayas, we have the high topography here comprising of folded Himalayan chain, and this is the boundary which marks the present day tectonic boundary between, or plate boundary between, the Tibetan plate and the Indian plate. And apart from the earthquakes which have been given here, this was of 2015, both these earthquakes. There are few more which have been experienced by this region, and one of the large magnitude earthquake, or the Great Himalayan earthquake, was 8.1 1934 Bihar Nepal earthquake. There are few more, but I am not going to get into detail right now of those, but you can look at that we have 2005 here, and then historical events are listed here, 1555 of Srinagar, and then there was in 1905 Kangra earthquake 7.8, and this was been considered as and was one of the devastating earthquake at that point of time. Then we have 1934, and we have 1950 8.4, and there was another earthquake which was on Shillong Plateau 1897 8.7 magnitude. So, looking to so many earthquakes of very large magnitude ranging from above 7.6 ranging up to 8.7. The most important part which the scientific community learned this time in 2015 7.8 earthquake of Nepal was that why the damage pattern was different which was experienced if we compare 1905 7.8 magnitude. The magnitude was very much similar. Now, if you look at further, what we see here is that we have the distribution of the earthquakes, foreshocks, aftershocks, and the main shocks, which have been shown here. So, this is basically the rupture area which was been identified based on the distribution of the earthquake or the occurrence of the earthquakes. Now, one interesting thing which was been noted here was again that this was the main shock 7.8, and then we had another earthquake of 7.3, but other than that we kept on having the earthquake like magnitude 6.6, which is again a moderate earthquake, but yes, of course, we sitting at IIT Kanpur in the Indo-Gangetic plain felt all these events 6.3, 6.7, 6.6 also, and along with that, of course, this were also been we experienced. Now, this shows this map here, the time series which was plotted, which shows the plot of earthquakes occurred in Nepal from 25th April 2015 to 30th May 2015. Now, two major events which are been listed here are been shown here in the red dots. That was of 25th April 2015 and another was Gorkha earthquake of 12th May 2015. And you can see the earthquake occurrence, that is the number of earthquakes which were occurred, and then slowly the seismicity dies out and again it picks up, and then we are having, and in between we are having this magnitude earthquake which I was showing of magnitude above 6.6 like 6.6, 6.7, 6.3 and so on. Now, this is all information is extremely important for the seismologists and the people who are dealing with seismic hazard assessment of any particular region. In particular, we all understand that this region that is been shown in green, that is we are having the Indo-Gangetic plain is thick alluvium will be affected the most, okay, if we are having the earthquake of similar magnitude in the foothill zones. Now, what I believe is that if this earthquake would have occurred like few kilometers along this boundary, then the damage scenario would have been different. Another important thing which was been compared and observed was that usually the earthquakes with similar magnitude will be triggered and they release the energy very quickly, but here the oscillation was very subdued type. So, here there are like earthquakes which have been given here in black, blue, green, yellow, red. Red is your Nepal 2015 7.8 magnitude. Here it showed a different acceleration as compared to what was been observed in the Imperial Valley earthquake of 1940, Loma Petra in 1989, Kobe 1995, North Ridge 1994. So, this was one of the reasons that the damage was not much in the areas, in the epicentral areas as well as away from the epicenter area. Otherwise, we would have faced very huge damage. Another reason could be that this earthquake was triggered in the inner part of the hinterland side, not in the frontal part, because if you put the sketch here, like the section which has been shown in the first figure here, the earthquake was somewhere in this region. It did not rupture this portion. Now, another a lot of studies have been talking about that this event occurred somewhere here and the next event will rupture this portion. So, we can expect a similar earthquake which was experienced in 1934, and that could be more devastating for the people who are living in the Indo-Gangetic plain, because the damage pattern will be much higher and the ground shaking will be much higher. So, we decided to take up a complete field survey, and this was the travel plan. We started from Kanpur, moved to Gorakhpur, and then we covered this part of the area because we wanted to see what is the damage pattern over here resulted by the Gorkha earthquake, and then we moved towards the eastern side covering this area and to look at the damage pattern, which was in twofold, like I can say the initially by this and later on by this earthquake, that was 7.3 12th May 2015 event, and then we moved out and came back by the same the other route from the other side and covering the areas in the Indo-Gangetic plain. I'll show a couple of the damage pattern which we observed. I am not going to get into the detail that what was the the problems with the construction and all that, but very briefly I can talk about. But we will mostly see that why this was the damage was not much, even though we were having a magnitude of 7.8. The reason one, which has already been given, comparing the other earthquakes from different part of the world and the Gorkha earthquake, that the acceleration was quite different, which we observed. It was just like an seesaw which slowly moved and moved the earth crust, but nothing much was happened. But then also we see a considerable damage. So this is a seismogram of 2015 Gorkha earthquake. And so this was the event which took place and recorded at the seismic station in Tucson. These are the information which are available from NEIC, USGS about the origin time and the epicenter, what was the depth. Now this is also extremely important for us, at what depth the earthquake is occurring, because that will have a lot of implication in terms of the damage. And of course another important is what type of earthquake. This we will be talking later on, the thrust type and the strike slip type and all that. But this part is important. This was a very shallow earthquake, hence the damage could have been more actually. Now casualty figures which we collected, and we got the information from the local people as well as from the governmental organization, such as that maximum number of human fatality was in Nepal, and not only in Nepal but few deaths were also been reported from India. Injury was more than like 22,000, and in India the injury was again, and this were all mostly related to in the areas of Indo-Gangetic plain. So if we take the casualty figures in India, Bihar, Uttar Pradesh, West Bengal, Rajasthan and Sikkim, it definitely shocks were also felt up to Rajasthan, so it's sitting very far. So Bihar was maximum 58 people got killed in that region, and so on. So this was just like the figure which we got from the MHR report. This is a shaking map which was prepared based on the damage pattern. So you can easily make out that these were the two epicenters, epicentral areas where maximum damage was been experienced, comparative maximum damage. And then if we move further in the Indo-Gangetic plain, the intensity of ground shaking and damage pattern is reduced. So it was like here it was up to 10, and then here it becomes around 9, and then further it is around 7 here. And then in the Indo-Gangetic plain it was almost like around 6. So this shows the clarity is more here in this map. So here it was maximum, then slowly it reduced and went down to up to 4 also in some part of the areas. So this area particularly will be quite going to be affected if we are having the large magnitude earthquake. So one, it occurred somewhere here, okay, but next if suppose it takes place somewhere in this area, then along the front, then the damage pattern will vary. So we slowly moved and from the Indo-Gangetic plain, even we tried to interview the people in India and in the border areas, where we were talking that what was the experience they had during the earthquake or before the main shock started, that is particularly the seismic shaking started. So we were talking to people and trying to understand that what was their experience. Some people told that there was lightning and thunder and all that, and some people told that there was a roaring sound. So that was very important for us to understand, and as we moved further close to the epicentral area, we found that the damage was increasing slowly, and we saw more of the building collapse and all that. Otherwise, at the initial stages, when we started moving from the Indo-Gangetic plain and entered into the Nepal, we found some cracks which have been were visible in the structures, but no collapse was been seen. Then when we moved further ahead, most of the houses with brick masonry and mud mortar, they suffered damage in the villages. And this again, then another figure which has been shown photograph here, collapse of the first floor, and this was stone masonry package. So this also points out that most of the damage, which even though we say that it was in some villages experienced massive damage, was because of the poor construction. Of course, other the geological processes we were able to observe was common. Most of the areas experienced landslide because of the strong ground shaking or seismic shaking. Then this was at Kathmandu, in the main city. Now, failure of those houses, the civil engineers and the structural engineers can tell more about this, but this was the damage because of the poor construction again. This is at the Pashupatinath temple. Even though very old construction, but it still remain as it is. Very light damage was been observed, as you can see here. And then, so this is the part which was damaged, and again some structures which are associated with the temple experienced the damage. Otherwise, there was no major collapse which we observed at this point. The newly constructed structures experienced a huge damage, and in some places what we found was the construction has taken place. Now this construction, this house has been constructed over a artificial fill, and what you see here are the cracks which have been developed. It's an extensional crack. So at some point of time, this whole mass which has been filled mass on the in the area close to the slope will slide down. So this is not a good place to be selected for any construction. Another devastating and people mostly they got killed was at Dholdar Harihara Tower in Kathmandu. Now this tower was the tallest monument in Nepal and the second such tower built by Bhimsen Thapa. And of the two, the 11-story high first tower was built in 1824. Now there was an earthquake in 1803 and later on there was an earthquake in 1833 also in this region. So 9-story was almost like around 61.88 meter high. Second tower of Harihara, also known as, it was named as Bhimsen Tower. Now this tower experienced the massive damage, or I can say total damage of that. Now this is important point that during the earthquake of 26 August 1833, both towers survived, though the first one was quite severely damaged. However, under the influence of 1934 Bihar-Nepal earthquake, this was in the earthquake above magnitude 8, the first tower was completely destroyed, and in the second one only 2-story remained standing. Now the question comes here that these people knew that this tower is getting affected every time in different earthquakes. Then also they constructed without keeping in mind that there will be earthquakes or there will be more number of earthquakes in near future, and this occurred on 8 to 2015. Once again demolished it completely up to its, and only the basal part remain standing. So this is the before the Harihara Tower, before the earthquake, and this one is after the earthquake. So it was completely destroyed. That definitely the construction was not up to the mark to withstand even the earthquake of 7.8 with a very different acceleration. Now, what we observed was most of similar structures like what we see the Harihara. This is a chimney which most of the chimneys in this area got damaged, and this was very much similar phenomena which we observed or this area of the Harihara experienced in the region. Along with this, the damage, we also saw some land deformation which occurred. Now, there are two views. Again, debate is there that this area, or which is the area, it is the main highway in close to Kathmandu. So we found surface deformation which was resulted because of 2015 Gorkha earthquake. What we saw was that the area was subjected to the NHL fracturing, and the strike was thus actually this was what we found, and the NHL fracturings at some places resulted into the land uplift and subsidence, uplift, subsidence, and uplift, like that. So we did little bit detailed survey, and this area extended for almost like 400 meters. So these were the pictures which were been also available on the net, which shows the damage pattern where the roads and the bridges were buckled up, huge deep cracks were been formed. But our idea was that let's go and try to study, if possible, to see subsurface what exactly has happened. And of course, we were not able to go much deeper, but with the help of ground penetrating radar, we tried to see at some location that what is the features which we see in such pattern of deformation in subsurface. So this portion clearly shows a very well developed scarp here. This side is up, this side is down, and close to on the same line in the veranda, we see this portion is up, and you can see this portion is coming down here. So land level change was reported, and on the crust of the warping which we saw, the area which was up, we saw the extensional cracks which were developed, and extensional crack were quite deep. So what we decided that let us do a GPR across this so that we can see that how deep the cracks are, and what is the deformation which has occurred at greater depth. So we did GPR. Of course, as I told that we were not able to go deeper, but what we found was that, so this is an unprocessed profile without topographic correction. The topographic correction is this one, we applied to it, and what we found was there are the cracks. This was the zone of deformation. The extensional cracks developed on the warping side. So if you warp anything, then the crust will show you some openings, okay, or the cracks will form. The extensional cracks will be seen on the crust part. So this is very common. So these extensional cracks were observed here, but at the deeper portion, what we saw that there is another similar deformation which has occurred, probably not due to this earthquake, but of the past event, okay. And this warping was experienced in the past also. So this area must have experienced such a type of deformation in the earthquakes during the historic time. Very commonly found secondary features or the secondary effect in most of the areas where the water table was very shallow. We found the formation of the sand dikes and sand blows. So, this part again we will be talking in the ground effects, but of course, this I would like I wanted to show you when we are talking about the Gorkha earthquake. So, this was another important. So, this phenomena is going to be dangerous for the people who are staying in the Indo-Gangetic plain or the areas with thick alluvium, because liquefaction, even the earthquake occur at the distance from the site of interest or where you are staying. If the site conditions are ideal to trigger liquefaction, then you are going to face this type of issues. So, this is a typical of liquefaction sand dikes which are coming up, and this sand has been the liquefied sand which has broken these layers and coming right up to the surface because of change in pore water pressure. So, post earthquake Google image of Bagpur, that was the village which was in the epicentral area of Gorkha earthquake. Maximum damage was been experienced. Now, because of the connectivity of the roads, we could not reach this place, but the local people, the survivors, they told us that this Bagpur village experienced the huge damage, and that was mainly because of the poor construction, and the construction was done using the stone and mud machinery. Landslides were very common in most of the valleys close to Bagpur, and this area experienced the maximum intensity in terms of the ground shaking. So, thank you so much, and we will continue in the next lecture, talk more about the different hazards. Thank you.